Good morning, students. Today we'll start your new chapter number 2, that is electrostatic potential and capacitance. So in this chapter, two topics are there. First one is the electrostatic potential and second one, that is a capacitance. So initially we'll start with this topic of electrostatic potential. But before going to start this chapter, just recall the few equations from your previous chapter of electric charge and fields. So as you know that the equation of force or equation of electric force that we derived from Coulomb's law, that is K Q1 Q2 upon R square. Right? From that force we derived the equation of electric field, that is E is equal to F upon Q. And we used a number of other equations, but those equations are not required in this chapter, so we will not discuss about it. So let's recall a few other equations which you have already seen in your chapter number 6 in 11th standard, that is work energy theorem. So in that portions we have seen that work done can be equal to the change in energy, and that change in energy, that is the sum of potential energy and kinetic energy. Okay. So if you get the value of work done, so you can say that this is also a energy. Here in this chapter number 2 we will discuss about the electrostatic potential, but with the conditions that all the things occurs in a vacuum. So as we know that in vacuum, change in velocity that will equal to 0, and any particles that will move with this constant velocity. If it moves with the constant velocity. If it does not move, so that will remains in its stationary stage. So here we will take kinetic energy that is equal to 0, so that work done is equal to change in potential energy. Okay. So let's start with one. I'm taking one example. Suppose any particle lies at this infinite point P. Okay. So point P is at infinite distance, and if I have to bring this charge, suppose this is a charge Q, small charge Q, and if I have to bring this charge up to point, suppose this is R, in a given electric field, that electric field that is because of this charge positive Q. So to bring this unit charge Q into the given electric field, so I have to apply some force, as the vacuum is there, so the acceleration is considered as equal to 0 in this case. So this external force which I have applied, that is opposite to the direction, that is opposite to this direction of this force due to electric field. Okay, so I can write it as a force due to electric field that is equal to F force due to external force. Okay, but minus sign is because of both are in opposite directions. So now suppose this to move this charge from this infinite to the point R in a given electric field at a in a given electric field at a distance of R. So as the force is applied, force is applied and displacement happens, so I can say that it is a work is done on this unit charge to bring from infinite to the point R at a distance of R from a given point, from a given source charge. So I can write it as a work done is equal to integration of external force into displacement, that is dr, that is for small particles, and this force and the displacement both are in a vector quantity. So in place of external force I am writing as a minus Fe. So work done is equal to minus from infinity to at a distance of R, Fe into dr, Fe dot dr. Okay, so this will be the work done, and this work done, as I have discussed about that work done, that is converted into the change in potential energy. So I can say it as a this work done is utilized for storage of potential energy. Storage of potential energy. Okay, so I hope up to this clear to you. And here we bring this charge q from infinite to point r, so it does not depend upon the path, it only depends on the initial and final positions. So you can consider any path, and based on this concept we have another new terminology, that is electrostatic potential. We denote this symbol of electrostatic potential as a V. And what its definition is, it says that work done by the external force in bringing a unit charge from infinite to a point in a given electric field with zero accelerations is known as an electrostatic potential. Okay, so simply I can say it as a electrostatic potential is what? That is the work done in bringing the unit charge from infinite to the given point in an electric field without any accelerations. That is a electrostatic potential. So V is equal to work done upon Q, that is a unit charge, and as the work done is a storage of potential energy. So if I consider this point P, consider point R, so I can write it as a UR minus UP upon Q. Okay, so that is VR minus VP. So that is your electrostatic potential V. Clear? And unit of this electrostatic potential, that will be watt, or you can also consider it as it's a work done upon Q, so joule upon coulomb. Okay, so that was a concept about electrostatic potential. Now we'll discuss about one topic, that is a potential due to point charge. So in simply we will derive these equations of electrostatic potential because of a point charge. Okay, so suppose I am considering this as any source charge, any source charge Q and any point charge at infinite locations. Now if I have to bring this point charge from infinite to the given point, suppose this is a point P dash, suppose this is point P. If I have to bring this charge from infinite location to point P in a given electric field, so initially suppose I move this charge from P dash to any given point, infinite to suppose infinite location to any given point P dash, and its locations from this charge Q, that is location from the charge Q, that is capital Q, that is R dash. Okay, so now the value of electric force of charge of this unit charge because of this charge Q at point P dash. So as we know that F is equal to K Q upon R dash square into R dash hat. This is in a vector form. Okay, and as we consider this small q as a unit charge, so the equation will be kq upon r dash square into r dash hat. Clear? So that will be the equation of force at point, electric force at point P dash. Now if I go through the displacement, small displacement delta r dash, so for this small displacement delta r dash, the work done, that is equal to F dot delta r dash. Okay, and as you know F is equal to kq upon r dash square r dash hat into delta r dash. So this is the equation of work done for a small displacement portions. So the from this total displacement will be total work done, that will be from bringing this charge from r dash to r. So I will consider this in terms of integrations from r dash to r. dW. So that is equal to k q upon 4 pi epsilon 0 kq upon 4 pi, sorry, no, it won't be 4 pi epsilon 0 because k is equal to 1 upon 4 pi epsilon 0. Okay, so here as we have the equation of work done, dW is equal to F dot delta R. Okay, as this force, this external force, that is as this force is acting in these directions and this R is in these directions, so both are making an angle of 180 degree. So if I use this scalar quantity is low, so F, this will be F delta R dash cos 180, and that is equal to minus F delta R dash. So here I will write it as a integrations R dash to R minus F delta R dash. So I will just put this value of F. So I will get KQ, minus sign is outside, and delta R dash. So I will write it as a, sorry, R dash to R 1 upon R dash square into dr dash. So if I simplify this integrations, so equations will be minus KQ, the integration of this is like this one, integration of x raised to n is equal to x raised to n plus 1 upon n plus 1. If you use this formula for the same equations, here r dash raised to minus 2, so minus 2 plus 1 upon minus 2 plus 1, so that will give you a minus 1 upon r dash from r dash to r. Okay, so that is minus KQ. If I consider this r dash as an infinitive portions, so the equations will be 1 upon r minus 1 upon infinitive. So finally the equations will be KQ. I am taking this minus sign as a outside, minus sign I have taken it as a outside, so this will become plus. So that will be KQ upon r. So that is the equation of work done, and as we know that this electrostatic potential is what? The work done upon unit charge q, and already we have considered this unit charge as a 1. So KQ upon R, that is the equation of electrostatic potential because of the point charge. Okay, so I hope up to this clear to you. So next time I'll start with the theory, that is one of the important theory of the chapter, that is the potential due to an electric dipole. Okay, thank you.